in the past, we've always talked about horizontal and vertical translations towards parabolic shapes, such as a bridge. But now we can apply translations to new types of functions. But before that, let's just review the parabolas first. If we had to graph y equals x squared, which is the original parabola, and then also y equals x squared plus 2, you know that the plus 2 is going to move the whole graph up 2. But if we had to do it anyway, you can use a step pattern, vertical steps and horizontal steps, go over 1 up 1, over 1 up 3, and then over 1 and up 5 from the vertex of each of the equations. And then you should expect something like this. So the original one is the one in black, and then the one that's been translated up to is the one in orange. Are they both functions? Yes, they are, because for every x value on each of those graphs, you have only one corresponding y value. The domain for the black is going to be all real numbers, because since it goes up and up forever and it gets wider and wider, you'll always have a point on the graph that has an x value. The range, however, looks like that the graph only goes up forever and doesn't really go down past 0. So y belongs to all real numbers, but remember that y has to be greater than or equal to 0. For the other one, the domain is going to be all real numbers again, but then since it's been shifted up to, the range is going to change to y belongs to all real numbers, but y has to be greater than or equal to 2. Okay, so that's the part of the review on parabolas. Let's start applying these translations to new kinds of graphs. If we have a base graph of y equals root x, and we add a number or we subtract a number, it's going to do the exact same thing that it's always done. It's going to move the graph up and down. So if we use the step pattern for the root graph, it is over 1 up 1, over 3 up 1, and then over 5 and up 1. So the graph looks like this. That's the original graph. Now you're expecting that probably if we add 3, it's probably going to go up 3. And then if we subtract 2, it should go down 2. So there is the up 3, and there's the down 2, just as we would expect. Okay, now let's talk about the domain. The domain of the original is anything from 0 and onwards this way. There are no x values the other way. The graph doesn't go that way. So if we take a look at the orange, it's going to have the exact same domain, and so should the green. Because technically, by moving it vertically up and down, you haven't changed the horizontal part of the equation. You've actually changed the vertical part of the equation, and we'll see that when we do the range. So the range, again, if you're talking about height, this line has a height of 0 as its minimum, and then it goes up and up forever because it looks like it's slanting upwards. Okay, so y has to be greater than or equal to 0. And for the range of the orange, though, you didn't start at 0, you've now started at 3. So it has to be greater than or equal to 3. And you can just imagine for the green, it has to be greater than or equal to -2, because that's where it started. So an overall rule, when we add k to the overall function, whether it be an x squared graph or a root graph, if k is greater than 0, it's going to move it up k units. If k is less than 0 or negative, it's going to move it down k units. The exact same rules as for parabolas. Okay, now what happens if we have the +2 and the -3 underneath the root sign? So not on the outside of the root sign, it's now on the inside of the root sign. Okay, so first of all, we're going to do the same step pattern to graph our original, and then this is going to move it left 2 versus this one, which is a right 3. Okay, so left 2 for the orange and right 3 for the green, which is what happened before with parabolas. Since it's moving left and right, it's going to affect the horizontal component, which means the domain is going to change. So the domain for the orange is now x values starting from -2 and onwards. So it has to be greater than or equal to -2. And then the domain is starting from 3 and onwards. So it has to be greater than or equal to 3. But notice that we haven't moved up or down, we've just moved left or right. So the ranges should be exactly the same. If we then have our h value, not our k value, and we start manipulating the h value, if it's greater than 0, as in if this is a positive number in the bracket, plus h, then we're going to have it move to the left. But if this number inside here, including the symbol, is a minus, then you're going to move to the right. Okay, so let's just try one. Here's f at x. I just drew some weird squiggly line, okay? And what I want to do to it is notice there's a -2, but there's also a +4. So now we're going to predict what it looks like. Now this looks like it's my k value because it's on the outside of this bracket. Okay, so I'm probably going to go down 2. And then this guy, since it's inside the bracket with the x, I'm thinking that's a left and right component. That's my h. So I'm going to go to the left 4. What you're going to do is you're going to pick points all along here. So this looks like it's a good point. Maybe this is a good point. Maybe this one's also a nice good point. And you're just going to shift all of those to the left 4 and then down 2. Okay, so there's the left 4 component and then down 2. That's our final graph. Okay, and that's it. We're finished.